Now let's take a closer look at the needle itself and label its parts. At the top of each needle is a hook. Below this is a latch attached with a rivet. Notice that the bottom edge or cup of the latch is curved to fit over and completely close the hook. At the bottom of the needle is a butt, which plays a part in controlling how needles activate, up or down. A needle with a latch is very efficient. When latch needles are used to create knit fabrics, the knitting cycle can be completed without any auxiliary attachments. Here's how the latch needle works. At rest or running position, a knit loop rests above or on the latch. As the needle moves up, the old loop, already formed, drops below and clears the latch. As the needle moves down, it receives the new yarn to begin forming a new stitch. The latch is knocked over by the old loop, and this old loop is cast off. The needle moves further down to fully form and complete the new stitch. This stitch, called the knit or jersey stitch, is the foundation of all knitting. The amount of yarn used to form a new stitch determines the stitch length. This is important because stitch length affects the weight, tube size, performance, and aesthetics of the sock. On modern-day sock knitting machines, each needle makes thousands of loops or stitches a day. Needles may need to be replaced due to wear, but they usually last up to several months, depending on construction, yarn type, fiber type, and speed. Next, let's take a look at what causes the needles to move up and down. In this side view illustration, you see how the butt of a needle guides the needle through a path formed by cams. Each cam is designed to allow the needle to run straight or to move up or down. Here's how the needle travels through various stages. At the rest or running position, the needle runs straight over the rest cam. When it hits the clearing cam, it rides up at a steep angle, which forces the needle to rise and clear the old loop. Then the needle drops when it contacts the stitch cam. As it continues on its path, it catches the new yarn. It continues further down, pulling the new yarn far enough for a new loop or stitch to form as the old loop is cast off. The up throw cam returns the needle to its resting position so it can begin the cycle again. Take a look at this same action while the machine works. Watch how needles run through the camways, causing the needles to rise and fall. And remember that this machine has a cylinder that contains vertical grooves and slots to hold the needles that move. As needle activation occurs, how does the machine control the movement of the sock fabric as it knits? What prevents the fabric from riding up and down on the needle? There's one more part placed between each pair of needles that better explains this. It's called a sinker, and here's what it looks like. A thin steel element with a distinctive shape. This illustration highlights the parts. A sinker has a butt with a place to insert a cam. It has a hold, a throat, and a nose. As the needle goes up, the sinker moves in to catch the sock fabric in its throat. Since the fabric can't go up with the rising needle, the old loop now clears the latch. When the hook catches a feeder yarn as the needle moves down, the sinker moves back out of the way, and knockover, cast off, and stitch forming takes place. As the new stitch is formed, the fabric rests on the top of the nose. In sock manufacturing, the sinker is specially designed to form terry loops on the inside of the sock. These terry loops provide cushioning for the sock and are discussed in detail in the sock components segment. This sock is inverted, so the terry loops can be seen on the heel, sole, and toe. This is a common sinker used in sock manufacturing. It holds down the sock during the needle activation and is also used to make the terry loop inside the sock. Notice there is a throat at the bottom of the sinker with a hold just above. The hold controls the fabric already made into cloth. The nose is used to form the terry loop used as cushioning in the sock. Notice that there are two yarns used in this fabric. The yellow yarn is used for the terry and is on the back of the tube, while the red yarn is on the ground of the fabric. Here's one last view of needle activation with the dial lifted to show you how knit fabric is formed in real time. When making the sock tube, the cylinder rotates through the yarn feeding and camming stations to cause the yarns to knit. This view shows the dial, with the transfer bits being raised up out of view so that the action of the knitting elements can be seen. Normally, of course, the dial would be down in order to make the welt. Courses upon courses are made in this manner. However, an advantage of the sock knitting machine over the traditional apparel knitting machine is that the sock machine cylinder can reciprocate to create special areas of the sock. These areas are the pocket heel and toe. This special aspect of the sock knitting machine will be covered in the segment on sock components. Another characteristic of the sock knitting machine is the ability to add an additional yarn or yarns in selected areas for various reasons. Among these reasons are reinforcement, cushioning, logos, and many others. For example, this sock shows the white, gray, and black yarns having been knit. The white yarn is the ground yarn and makes up the majority of the sock. The black yarn is added for improved abrasion resistance. The gray yarn is in the toe of the fabric, both as a ground and in the terry area. It also provides abrasion resistance and improves aesthetics. With this technology, only the needles where the effect is desired are selected. All the other needles in the cylinder knit the ground yarn of the sock. More details will be revealed in the sock components section.